The complex number, as we have said before, in the standard form looks like this. So a plus bi, where the a plus bi corresponds to the points a and b. This point is in the complex plane. So what is the complex plane? The complex plane is basically the Cartesian plane that we know of, but in the horizontal axis is going to be the real axis A, and the vertical axis is going to be the imaginary, which is going to be the BI. So let's say we have this point in the complex plane, and that corresponds to 2 and let's say 3. So the point is going to be 2 and 3. And if you want to write that point in the standard form of complex numbers, is going to be 2 plus 3i. Now let's say that if it was in the third quadrant and we had, let's say, -1 and -2. So then it would have been -2 minus 1i, or -2 minus I. So we use the same form as the Cartesian, but the x-axis that we had in the Cartesian is going to be the real value of the complex, and the y-axis is going to be the imaginary axis for us. Now, how do we find the length of that point that we have? So we get it from the center, which is 0, 0, and we know that the absolute value of a point in plane is going to give us the length. So here, if we get the absolute value of a plus bi, that would give us the distance from that point AB to the origin. So this one is going to be the root of a squared plus b squared. And we will call this r as the length of the complex number, or in some textbooks they call it as modulus. So now that we have the r, we also need to know the other components of it. So the a component on the a axis and on the b axis. That's easy to get. So we use the sine and cosine, and we say cosine of theta is going to be a over r, and sine of theta is going to be b over r. And now that we know the complex number, in order to write the polar form, we need the sine and cosine. So the general term for the polar form that we had, so a plus bi, transforming it to the polar form, is going to be r. So is going to be r cosine of theta plus r sine of theta multiplied by r. So all I did was substitute a from this and b from this one. So b is going to be r sine, a is going to be r cosine. So I substituted. Now I simplify this one a little bit more. I factor out the r, then it becomes cosine theta plus sine theta, and then I have the I, and we put the I before the sine, and that's the polar form. So if you have any complex number given to us, in order to write it in the polar form, first we need to get the length or the modulus of that point, and that's how we get it. So it's going to be a squared plus b squared, the square root of the whole thing, and then the cosine of theta, the angle, plus I sine of the theta or the angle that we have, and that's how we can get the angle. Um, Now, this is the sine and cosine, but the easiest way to get the angle, we know that the tangent of theta is sine over cosine. So if I divide sine by cosine here, I will get b over a. And from here, theta is going to be the tangent inverse of b over a. And that gives me the theta. So the two important parameters that I need to find is r, which is the modulus or the length, and the angle. And that's how I get it from the tangent inverse of b over a. And then I plug into the equation for the polar form, r multiplied by cosine of theta plus I sine of theta. Now let's go ahead and do one example and see how we can solve it. So let's say that we are given negative root 3 plus I as our complex number, and we are asked to write it in polar form. So the very first thing is finding the value of r. We said that r is equal to a squared, which is this value, negative root 3. So negative root 3 squared plus b squared, which is the imaginary value. So we have only one as the coefficient over there. So that's going to be, so what I'm going to get, the square of negative root 3 is going to just give me 3 plus 1 squared, 1. So I have root value of 4, which gives me 2. So my r value is 2. Now I need to find the theta. So the theta, I said, is going to be tangent inverse of b over a. And I have b as negative root 3, sorry, rather b is plus 1, and a is equal to negative root 3. Now, if I do a little bit of multiply the whole thing by root 3 over 3, I get tan inverse of negative root 3 over 3. And from the unit circle, we know that where this one lands in. So it's a negative. Which quadrant it is? It is in the second quadrant, right? So my value is going to be 5 pi over 6. So I'll put the link for how to get the values, the fundamental or the most important angles in unit circle, in the link below, so you can go over and review the unit circle. So that's my theta. Now, in order to write that in polar form, so negative root 3 plus I is equal to r, which is 2, cosine of 5 pi over 6 plus I sine of 5 pi over 6. And that is the polar form of that complex number. Now let's do another example. In the second example, we are going to have the complex value or the complex number of negative 2 plus 5i. And we want to write this one in the polar form. So the very first thing again, finding the value of r. A squared, negative 2 squared plus 5 squared. And so what do I have is 4 plus 25. It's going to give me root 29. That's my r. And then I got to do theta. Theta is tangent inverse of b over a. So 5 over negative 2. So for this one, but it's not one of those angles that we could say what it's going to be. So the easiest way is just using a calculator and getting that angle. So when you put it into the calculator, remember, you are going to basically get the tangent of 2.5. So you need to know that which quadrant is your angle in. So our angle is going to be in the second quadrant. So in order to know that in which quadrant it's going to be, you can do the cosine and sine. So the cosine is going to be a negative value, negative 2 over root 29, and the sine is going to be a positive. So sine is positive in the first and second quadrant, and cosine is negative in the second and the third quadrant. So, so we are gonna have it in the second quadrant. So that's how we can figure it out. And now, if you get the tangent inverse of this value, the theta that we are going to get is going to be negative 1.19. Now, from this one, in order to get the right angle, we need to add pi to it. And in polar form, we always use the radians. So our theta is going to be 1.95. So that's my theta. Now, from here, I can go ahead and write the polar form of the complex number negative 2 plus 5 I. And my R, I said, is root 29 cosine of that theta. So cosine of 1.95 plus I sine of 1.95. And that's the polar form of that complex number. Now that we know how to get the polar form of a complex number, it's good to go over one of the properties of the polar form. One of them is the polar multiplication. So when we do the polar multiplication, let's call the first polar form Z1. Is going to be equal to R1 cosine of theta 1 plus I sine of theta 1. And then we have a second polar form of R2 cosine of theta 2 plus I sine of theta 2. And we want to do the first polar form multiplied by the second one, Z1 multiplied by Z2. And the way that we do, well, basically we got to multiply these two by each other. The result is going to be basically R1, R2 cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And that's the multiplication. So when we do the multiplication, the r's multiplied by each other and the angles, they get added. Now, what if we want to divide them? So dividing them, as you would guess, is going to be R1 divided by R2 cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. So that's how we multiply and or we divide the two polar form by each other. This is going to be helpful when we want to prove the De Moivre's theorem. So De Moivre's theorem uses basically the properties of the polar multiplication and proves its theorem. We will get to that later. But the proof of how this happens is pretty easy. So let's go over and see how we can prove this. So if we do z1 multiplied by z2, we are gonna have, well, basically r1 cosine of theta 1 plus I sine of theta 1. And this whole thing getting multiplied by r2 cosine of theta 2 plus I sine of theta 2. Now, so we do the multiplication and see what we get. So we get r1, r2. So I'm just multiplying the terms that I have. So r1, r2, and then cosine of theta 1 plus I sine of theta 1 multiplied by that. So let me write that too. Cosine of theta 1 plus I sine of theta 1 multiplied by cosine of theta 2 plus I sine of theta 2. You can skip some of the steps that I do, but I'll go in a small step so that we can visualize and we can see exactly what's going to happen. So now I have the R1, R2, I do the multiplication of the cosine and the sine. So it's going to be cosine of theta 1, cosine of theta 2, plus I cosine of theta 1, sine of theta 2, plus I sine of theta 1, cosine of theta 2, plus I sine of theta 1, I sine of theta 2. So that's how what I get from the multiplication. Now it goes to simplifying. Okay, if you look here, we have I multiplied by another I. So I have I squared, which is negative 1. So that's going to be the negative value here. So let me do some simplification and write this again. So R1, R2. So cosine of theta 1, cosine of theta 2, plus I will bring this again. So I cosine of theta 1, sine of theta 2, plus I sine of theta 1, cosine of theta 2, plus or minus sine of theta 1 sine of theta 2. So we said that the I squared becomes negative 1, so I will have a negative value here. Now the next step is grouping them together. So what I can do is to get the terms that I know they're going to be one of the identities. So one of the identities that we knew regarding sine and cosine multiplication is the addition identity. The addition identity, what was the addition identity? The addition identity said that the cosine of theta 1 plus theta 2 is equal to cosine of theta 1, cosine of theta 2, minus sine of theta 1, sine of theta 2. So over here, what do I have? I have cosine of theta 1, cosine of theta 2. And then I need another one which says sine of theta 1, sine of theta 2. Do I have it? Sine of theta 1, sine of theta 2. So these two terms are going to give me the cosine of theta 1 plus theta 2. Now, what about the other ones? So what about these two? So if I factor out the I from these two, well, what am I going to get? So if I do the factoring, I'm going to get cosine of theta 1, sine of theta 2, sine of theta 1, cosine of theta 2. And that's the sine. So sine of theta 1 plus theta 2 is equal to what? Sine of theta 1 cosine of theta 2 plus sine of theta 2 cosine of theta 1. So that's basically what I have here. So these two terms are going to be this identity. So I'll rewrite the whole thing using the identities. So using the identities, the very first term that I had is this one. So it's going to give me the cosine of theta 1 plus theta 2. And for the sine, I said that I'm going to factor out the I, and then the rest is going to be the sine of theta 1 plus theta 2. Well, I don't need, let me get rid of this parentheses here. So yeah, I don't need that. Okay, now this cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And that's basically what we had as the multiplication equation of the polar for R1, R2, cosines, the thetas added for each one. Well, one thing that I missed here is the R1, R2. So the R1, let me get rid of this. So basically R1, R2 by that thing. So that's the proof of Z1 multiplied by Z2.